Epsilon Boötis, also named Izar, is a binary star in the northern constellation of Boötes. The star system can be viewed with the unaided eye at night, but resolving the pair with a small telescope is challenging. An aperture of 76 mm or greater is required. Nomenclature: Epsilon Boötis is the star's Bayer designation. It bore the traditional names Izar, Moroccan Izar, and was named Pulcherima by Otto Struve. Izar, Moroccan Izar, derived from the Arabic Izar meaning veil and Almaric meaning the loins. Pulcherima is Latin for loveliest. In 2016, the International Astronomical Union organized a working group on star names to catalogue and standardize proper names for stars. The WGSN approved the name Izar for this star on the 21st of August 2016, and it is now so entered in the IU Catalogue of Star Names. In the Catalogue of Stars in the Calendarium of Al-Aqsazi al-Muwaqqit, this star was designated Mintek al-Uwa, which was translated into Latin as Cingulum Lateratoris, meaning belt of Barca. In Chinese, meaning celestial lance, refers to an asterism consisting of Epsilon Boötis, Sigma Boötis and Rho Boötis. Consequently, Epsilon Boötis itself is known as properties. Epsilon Boötis consists of a pair of stars with an angular separation of 2.852 plus or minus 0.014 arcseconds at a position angle of 342°9 plus or minus 0°3. The brighter component has an apparent visual magnitude of 2.37, making it readily visible to the naked eye at night. The fainter component is at magnitude 5.12, which by itself would also be visible to the naked eye. Parallax measurements from the Hippocos astrometry satellite put the system at a distance of about 203 light-years from the Earth. This means the pair has a projected separation of 185 astronomical units, and they orbit each other with a period of at least 1,000 years. The brighter member has a stellar classification of K0e3, which means it is a fairly late-stage star well into its stellar evolution, having already exhausted its supply of hydrogen fuel at the core. With more than 4 times the mass of the Sun, it has expanded to about 33 times the Sun's radius and is emitting 501 times the luminosity of the Sun. This energy is being radiated from its outer envelope at an effective temperature of 4550 K, giving it the orange hue of a K-type star. The companion star has a classification of A2V, so it is a main sequence star that is generating energy through the thermonuclear fusion of hydrogen at its core. This star is rotating rapidly, with a projected rotational velocity of 123 km s-1 by the time the smaller main sequence star reaches the current point of the primary in its evolution. The largest star will have lost much of its mass in a planetary nebula and will have evolved into a white dwarf. The pair will have essentially changed roles, the brighter star becoming the dim dwarf, while the lesser companion will shine as a giant star. In culture, in one Star Trek episode, Whom Gods Destroy, the major character, Kelvin Garth, is also referred to as Garth of Izar. In 1973, the Scottish astronomer and science fiction writer Duncan Lunan claimed to have managed to interpret a message caught in the 1920s by 2 Norwegian physicists that, according to his theory, came from a probe orbiting the Moon and sent there by the inhabitants of a planet orbiting Epsilon Boötis. The story was even reported in Time magazine. Lunan later withdrew his Epsilon Boötis theory, presenting proofs against it and clarifying why he was brought to formulate it in the first place, but would later go on to revoke his withdrawal.